In this video I'm going to talk about profit and I'm going to take sort of a mathematical route through it. The mathematics are not complicated, but if you're not happy with the mathematics, then just watch out for the key statements, the outcomes. But for those of you who are curious as to why certain relationships hold, here are the proofs. So really these classes are ideally suited for those of you who have got a fairly decent mathematical background. Those of you who are not happy with that, just watch out for the key statements. I'll indicate what it is that should be remembered and what the outcomes of the mathematics are. So I'll indicate those to you. So let's start. We're going to talk about profit. Well, profit is just simply the difference between revenue and costs. So profit is equal to total revenue minus total cost. We write pi for profit. We can't write p because p is usually price. So when we write little expressions to show profit in economics, we usually represent it with the letter pi. It's not pi as in mathematics, the 3.14 whatever it is. So we're not talking about that pi. We're talking about pi, shorthand for profits. Now let's look at the theory of profit maximization, because we're dealing with a type of economics that's sort of based on the idea of maximization. Rational behavior would mean maximizing behavior. That's our working hypothesis. So to get this, we get marginal revenue, which is equal to the difference in total revenue with respect to the difference in quantity. So in terms of the calculus, it's dTR by dQ. And to maximize that, we set it equal to 0. So total revenue is maximized when marginal revenue is equal to 0. Right. Similarly, profits are maximized with respect to output when d pi by dq is equal to 0. That's how we maximize using the calculus. We simply differentiate one variable with respect to the other variable and set it equal to 0. So that's quite straightforward. That's if you've done a little piece of calculus. If you haven't, I guess that's sort of hieroglyphics, but you know. Now, we know that profit is equal to total revenue minus total cost. That's not rocket science. We have profit is the difference between total revenue and total cost. Okay. Now, if we take a small amount, a small change in profit, divided by a small change in quantity, if we do that all the way across, then that relationship must hold. It must be d pi by dq, which is equal to dTR by dQ minus dc by dQ. In other words, the first differential of profit with respect to quantity of output is equal to the first differential of total revenue with respect to output minus the total differential of total cost with respect to output. If you look at that expression, in a way we haven't done anything very big with it. We just simply said we'll take a change in pi. There's the change in pi, d, very small change, infinitesimal change. If we change this one, we must change over here. So we change that and we change that, and in a sense we divide everything by this. So we haven't really done a lot there. If we're going to maximize profits, we'd set it all equal to 0. That's what we do. We set things equal to 0 to find a maximum, or in fact to find a minimum. But more about that later. Well, we've just got our definitions here. Really what we've got is we've got the differential of total revenue with respect to output, this one here, that's just marginal revenue. This one over here is just marginal cost. That's the definition of marginal cost. That's the definition of marginal revenue. So there you are. So maximizing profit with respect to output, differentiating it with respect to output, and setting it equal to 0 means marginal revenue minus marginal cost is equal to 0. And just tidying that up, take this to the other side. So we've got marginal revenue equals marginal cost for profit maximization. That must be remembered. That's key. To maximize profits, marginal revenue must equal marginal cost. Obviously, in the world in which we live, there are big issues with doing this. For example, how do we measure marginal cost? How do we measure marginal revenue? How do we know where they exist, and how do we work them out? And lots of practical problems. But theoretically, that is the solution. That's what the theory would indicate where maximum profits exist. In fact, it's not quite as simple as that. I said to you earlier, this one up here at the very top, this one is maximum. This is maximizing profits. Well, yes, it is, but it's also maximizing losses. When you differentiate, when you take an expression like that and differentiate it with respect to Q, you found out the maximum or the minimum. So really, those of you who have done calculus will realize you've got to have a second order condition. You've got to differentiate it again to see if it's greater than 0 or less than 0. So this condition here is for maximum profits, or indeed, would you believe, hard to believe but true, it could be for maximum losses. So we need some way of making sure that we're picking up the profit one, not the loss one, because this rule will give us both. It will give us maximum profits or maximum losses. So clearly we don't want to maximize losses, so we need a second rule. So the two conditions for profit maximization are marginal revenue equals marginal cost. Okay, we've established that. And the second one is the marginal cost curve must be upward sloping. Now, we'll bump into this again in other videos, and this is called a second order condition. If you've done calculus, you'll understand this completely. If you haven't, just for the moment, take it as a second condition. There are two conditions for profit maximization. Marginal cost equals marginal revenue, and the marginal cost curve must be upward sloping. That must be remembered. Okay, let's get practical and look at a table and see what's going on here. See if we can identify things. There's an output table. We've got here output on the first column. The outputs run from 1 to 6. We have marginal cost in the second column, marginal revenue in the third column. Then we have one called marginal profit. We haven't met this one before. Marginal profit, and we have total profit. Let's just run down these for a moment. Output is equal to 1. Let's say marginal cost is 5. Let's say marginal revenue is 20. So the cost of producing the first one is 5. The revenue from selling the first one is 20. So the profit from selling the first one is 15. And we're only making one, so our total profit will be 15. If we make two units of output, the marginal cost of the second one has gone up to 7. That's the cost of making the second one. It's not an average, it's the cost of that particular item. The revenue from producing it has come down to 18. Well, maybe the consumers need to have a slight discount to buy the second unit, or market conditions, the price has fallen slightly, or whatever. But let's say the revenue from selling the second one is 18. The cost of making it is 7, and we get 18 from selling it. Therefore, the marginal profit, the profit on the second unit, is 11. 18 minus 7. We add that 11 to what we made on the first unit, we get 26. 15 plus 11. If we make 3, the marginal cost, i.e. the cost of making the third one, is 10. The revenue from selling the third one is 16. Therefore, the profit from selling the third one is 6. It's 16 minus 10. We add 6 to 26 to give us 32. So the marginal profit, the profit from the third one, is added to the 26 to make 32. On the fourth one, the marginal cost is 14. The marginal revenue is 14. So it costs 14 to make it, and we make 14 when we sell it on the fourth one. Nothing to do with the third one or the second one or the first one. This is on the fourth one only. It costs 14 to make the fourth one. We sell it for 14. No profit. So the total profit remains the same. And so on for the fifth and the sixth. So profit maximization, if you look at the results here, profit maximization occurs between 3 and 4 units. So it's somewhere in here. Obviously, if these were continuous units, if you're making litres of petrol, it's a continuous unit. You don't have to have a litre. You could half a litre or a quarter of a litre or whatever. We can divide up, and we can have 3 point something. If these were discrete units, i.e., units that can't be divided up, then we'd either produce a 3 or a 4. But somewhere in here is profit maximization. The profits are rising up to 32, then the profits are falling back, 25 and 8. So profits increasing and falling back. So there's our table again. I'll just change it around slightly. And here is here's our profit. I've just sketched it over like this one. Somewhere between 3 and 4, profit is at a maximum. So it's in there somewhere. And that's the point where marginal revenue equals marginal cost. It's got to be in there somewhere. Somewhere at that point. So what have we learned so far? Well, we've learned that profit maximization occurs when marginal revenue equals marginal cost and where marginal cost is upward sloping. If it's upward sloping, we rule out the possibility of loss maximizing. For marginal revenue equal to marginal cost, we could be profit maximizing or loss maximizing. To rule that out, we have marginal cost upward sloping. Right, let's look ahead in terms of diagrams to see if it gets a bit better. Here's our average cost. It's U-shaped, and we get that from production. As output increases, workers and machines become more efficient, average cost starts to fall. As output continues to grow, at some stage the factory gets too big, or the processing plant gets too big, it becomes complex, the machines start to wear out faster, workers are getting each other's way, it becomes congested, etc., etc., and costs start to rise. So we have a U-shaped curve, really reflecting the law of diminishing returns. I suppose it is the law of diminishing returns which gives us that curve. However, this cost curve, it also includes explicit costs. These are the costs of raw materials, labour, all of the things that go to make up the product, but it also includes implicit costs. That means it includes opportunity costs. It includes what could have happened to the capital had it not been invested in this particular business. So it includes implicit costs, opportunity costs, and it also includes normal profit. Normal profit is a cost. That may sound a bit strange, but normal profit is a cost. Companies go into business to make profit. If they can get 5% return in a bank, let's pretend, and they're going to get 5% by investing in this business, Why invest in the business? Why not put the money in the bank and relax and have an easy life? So they must make something over and above what they would have got had to put the money into the bank. So normal profit is just enough profit to keep them in the business. Anything above that is called abnormal profit. So normal profit is necessary to keep companies producing. Anything less, and they will want to liquidate their assets, put the money into an alternative investment and do something else. So our average cost curve includes explicit costs, implicit costs, or if you like, opportunity cost, and normal profit. Normal profit is a cost. It's integrated into our idea of average cost. It's one of the big differences between economists and accountants. We see costs differently in that sense. There's marginal cost. Marginal cost cuts the average cost at its minimum point. Marginal cost is upward sloping. Here's average revenue. Marginal revenue has twice the gradient of average revenue, and it starts at the same point. So its average revenue is sloping downwards, marginal revenue has twice the gradient, and starts at the same point up here. Now, the profit maximizing output here is at Q1. At Q1, marginal revenue equals marginal cost there. So that's the profit maximizing output level. That's the profit maximizing output level. Now the total cost of producing Q1 is that area. It's the average times the quantity, which is the total. That's the total cost of producing at that level. The total revenue is the average revenue times the quantity. So it's the area of this rectangle here. Now if we take away the total cost from the revenue, we get left this one here. And this is called abnormal profits. It's abnormal because normal profits are included in the curve. So this point here has our normal profits. That's the amount that's necessary to keep the companies producing. If they make anything above that, that's called abnormal profit. They're making more than they need to continue to produce. So this rectangle here, the greenish rectangle, that one is abnormal profits. That's the extent of the abnormal profits. So ABCD is abnormal profits, sometimes called excess profits, excess or abnormal profits. And that's a diagrammatic illustration of profit maximization. So why profit maximize? Well, if the entrepreneur is the owner and the manager, then maximizing profits will maximize income. If the entrepreneur is the owner and the manager, then the more the entrepreneur generates, i.e. the greater the profits, then the greater the income. So there's an incentive there, a direct incentive. Sometimes profit maximization may be forced on companies by competitive pressure. Sometimes companies are forced to be efficient because of competition. Competition within the country, or perhaps international competition due to competitive situations overseas. Now the criticisms of profit maximization. Well, why should companies profit maximize in non-competitive markets? Good question. Why bother? If they are monopolists, or if they have got market power, they don't have to profit maximize. They could just make enough and be happy and relax. They don't have to be that efficient. consumers will pay for it anyway, depending on the elasticity of demand. It's also the case that what we call the separation of ownership from control means that managers could steer the firm away from profit maximization and pursue their own interests. Companies are complex. Companies may be owned by one group of people, the shareholders, who are not actually involved in the business. Maybe it's the managers who run the business. And the managers have a different set of objectives to the shareholders. The shareholders want security of investment, they want high dividends, and they want a reputable company, a reputable, secure company for their investment with high dividends. Whereas the managers might want high salaries, good working conditions, long holidays, bonuses. They're different. So the separation of ownership from control means that the managers can steer the companies away from profit maximization. So finally, the criticism of profit maximization. Well, some studies suggest that businessmen don't use marginalist rules because of uncertainty surrounding decision making. It's highly unlikely that companies know where their marginal cost is or what the marginal revenue is. If you walk onto a production belt where items are coming through, perhaps being mass produced, it's very difficult to just point at one and say how much to make that one, that particular one, not the one before it, not the one after it, just that one. And if you can't do that, you can't use marginalism. So although the mathematics are very interesting and the whole thing looks quite interesting, it may not be very operational. Okay, that's an overview of profit maximization. As I said, if you're not happy with the mathematics, don't worry about it. Just remember that marginal revenue equals marginal cost, and the marginal cost curve must be upward sloping, and that will give you profit maximization. And then be wary of the fact that not all companies profit maximize, and economists don't believe that all companies profit maximize. It is just one model amongst many, and there are many others to be considered under a literature called the theory of the firm. Okay, that's it for now, so thanks for watching.